All right. Hello, everybody. Hello, everybody. Welcome to another IAEI News Live. My name is Thomas Dimitrovich. Today is a recorded session, unfortunately, but I'll tell you why. I am right now, see, this is 12 o'clock Eastern. So I will be on a task group call for the NFPA 70, National Electrical Code, Codemaking Panel 2. I chair task group number 1, and we cover everything up to 210.8, from definitions to 210.8, and we're in the middle of 210.8 debates. So I took Nihad, if you're out there, no, Nihad will be on my task group as well. We took Nihad's spot from 10 to 12:30. Doing the task group work over the holidays makes it tough. So anyway, that's what I'm doing right now, and I did not want to delay the IAEI News Live event from 12 o'clock. We have to get back on the schedule. I've got a cool topic today, I think an interesting topic, and it's going to be on cable trays. Hopefully, we have a good discussion today on IAEI News Live. We're going to talk cable trays, and it all starts now. All right, so we're back. Beautiful. So I am going to have, I do have my 2020 code book here. And a portion of my cover. You know, I got to get tape. I've got to get tape and put this back together again. But right now, this is a bookmark. I do have my 2020 edition. I have my 2023 code book. I also have my iPad sitting over here. And what I really like about my iPad is that I can pull up, when I find my browser, the NFPA link. So, and here's what I did. I bookmarked it because they changed their website, and I don't know about you, but when things like I get a new website, I have to relearn everything. And I have a FIFO or a FILO memory, first in, last out. So when I remember something new, something old disappears. So that is, I have to hit agree, I have to hit log in. All right, so I have NFPA link open. I should be able to, I gotta give it its Face ID. I should be able to call up NFPA link if I have to. And also, there are a few documents. We'll try to search this, the web via this, because there are a few industry references I think you may find useful. They are a part of this discussion. So we will use NFPA, or we'll use my iPad to look those up. All right, and I want you to remember this. My goal is to teach you to swim or teach you to fish. I want to teach you to fish. So I'm going to whatever I go out on the web to get, I'm going to let you see my journey so that you can do this for yourself. All right? Perfect. All right, so cable tray. Now, cable tray, you're not going to see it in a residential dwelling unit, but here, you know what? Here's my thought process. I was in a home one day. Where was I? I can't remember what state and what jurisdiction I was in. But I was in a home, and we went into the basement. Man, I think I was actually looking. I might have been when I went to St. Louis to look when I was looking at homes. In any case, we go into the basement, and I noticed along the edge of the entire basement was a cable tray of sorts. It wasn't a cable tray like you would see here. Okay, it wasn't a cable tray like this type of a tray where you have very large metal framing. It was a much lighter cable tray. And I would call it a tray. I wouldn't call it a wireway. Well, I guess the difference, right? But in any case, it wasn't like you would see, it wasn't like the type of trays that we see for data and communications. It was metal. If I'm not mistaken, yeah, it was. It was like a mesh. It wasn't a solid tray either. It wasn't plastic. But what was interesting was whoever wired that house used that tray instead of having to drill holes through every joist. Now, I don't know if they used more wire in the house by doing it that way, but I will tell you, there was not a single wire going through the joists right this way. They would come up out of the tray and run along the joist and go up, but they never went through. And I thought to myself, that was pretty cool. I remember, in fact, when I was younger, my cousin is an electrician. He bought we used to always have to get on a ladder, drill a couple holes, get off the ladder, move the ladder, get up the ladder, drill a few holes, get off the ladder, get up the ladder, all that jazz, right? And it was a real pain. And then you had the extension cord, and inevitably, I don't know if any of you do this with your extension cords, but I got into a habit because of that type of getting up on a ladder and getting off a ladder and pulling your drill with your cord and your extension cord. I got in a habit of, before I plug in this is what I would do. So let's pretend for a moment that this is my extension cord and this is the plug on the end of my drill. Instead of just plugging it in, and then what would happen is you're pulling it, and then it comes undone, and you're up at the top of the ladder, and you're getting ready to do this, and you're like, oh my gosh, I got to get back down off the ladder and plug the full thing in. So this is what I did. I would take my cord, and I would go like this, and I would go like that, and I would tie it, and then I would do this. And now, it's probably illegal use of that drill cord, but it worked for me for the longest time, and to this day I still do that. I wish, and there, you know what, and if you know of a product that is out there that would let you do this the right way without trying to crank this and create a knot out of your conductor, if there's a product out there that would hold that in, I would love to know about it. Put it in the chat, do something, because I'll buy it. I tell you, that is, it was always, and it still is frustrating to me, even up in my garage when I'm working on things. So in any case, that cable tray idea was a really neat idea. It saved, I can imagine, it saved all the time in drilling those holes. And what my cousin bought was, to avoid having to get up and down off the ladder, he bought this cool extension that you basically put into the drill, and then it was really long, and it was on a 45-degree angle for the drill bit. And we bought these shorter drill bits, wood bits, that you could stand on the floor and knock those out in no time without having to climb up and down on a ladder. But that cable tray idea, in my opinion, was ingenious. I just thought it was the cat's meow. And he ran, whoever did it, ran that cable tray along, I believe it was along around the entire perimeter of that basement. And actually, no, it was only on one side of the basement. So he took all the wires up and went down one side of the basement, and anytime he had to come over and up, they would come out of the tray and then staple along the joists. It didn't go along the whole way around the edge because the one side was finished. It was only on the unfinished side. And it came off the panel board, went down the wall, and it was secured to the joists. I don't know. If you've ever seen that, please put that down in the chat, because I just think that's the coolest idea. Rather than drilling all those holes. That takes a lot of time to drill holes. And then you have to worry about the HVAC and everything else that comes after the fact. All right, so let's get back to cable tray. Now, what I'm planning to do, I'm going to give you a little overview. Here's the thoughts. I'm going to cover materials. I want to cover some codes and standards. I can't do a session without covering codes and standards. I mean, it's IAEI News Live. And then we're going to show you a few case studies to help you understand and implement some of the guidelines that we have from our codes and standards. The code book I'm going to reference is the 2023 code book. And I believe it's a chapter 6. And for some reason, I know if I click a slide, I am going to, I think it was, I know it's chapter 6. It's not 695. I know that's fire pumps. What? Whoa. What? No, it's not. Not chapter 6. It's chapter 3, you dipstick. Chapter 3 is wiring methods and materials. So why would I think chapter 6? What was I thinking about? There's a reason I was going to chapter 6, and I'm sure that before the end of this presentation, we're going to get to chapter 6. But for right now, I'm in 392, cable trays. So 392 cable trays. I'm in the 2023 code book. I got to clean my glasses. Just had some popcorn. And you know, your fingers get all buttery with popcorn. All right. So let's talk. Importance of material selection. Now, you can see by this visual that material selection must be pretty doggone important. That rust, just think if you had that as your cable tray and you had cables in that tray, you know you're going to have to replace that cable tray. We can't expect that these types of materials to last forever out in the exposed to the great outdoors. Now, maybe that cable tray could be good for an indoor application, but I would think there's probably lighter materials on the market as well for indoor applications. But all right, so steel. There you go. Look. Oh, then indoor pre-galvanized. And then outdoor, they do have an outdoor steel structure. They have it's lower thermal expansion contract. Okay, that's a huge advantage. If you think about what is the function of a cable tray, it's to hold cables up in the air, right? And you know you're not going to buy one continuous run of cable tray, which is where most of the application issues arise with cable tray, is because you get these in certain feet of length, and then you have to assemble them together to get a longer length. Well, when you have a structure like this, expansion and contraction can be a concern. And when you have steel, it says lower, doesn't say it's non-existent, thermal expansion and contraction. So structural grade steel, and you can have ASTM 1011 or 1008 for your finish. You have an indoor and outdoor, so they do make this equipment for outdoors. Now, aluminum. They're doing a lot more with aluminum these days, aren't they? I mean, even in vehicles. You have, well, this is sort of the advantages. If you're into cable tray, you might be able to, I mean, field modification. I guess aluminum would be easier to modify in the field. Although I would not want to be able to, I would not promote field modifications of listed equipment, right? I mean, think about it. But it's easier to field modify, probably for, I'm not sure what kind of field modifications you would want to do. If you have any ideas for what you would do for field modifying cable tray, put it down in the chat. That's what this channel is all about. We share our knowledge, and I know there's a lot of knowledge out there. So strength to weight ratio, again, aluminum is going to be lighter than steel. And it's an excellent grounding conductor. That's interesting. It's going to be lighter than steel, so the strength to weight ratio, I believe, from a structural perspective, that's what they're talking about. Copper-free, marine grade, aluminum. It's aluminum. And then they have stainless steel. Now that would be, I would think your stainless steel would be for those corrosive areas. Do you have any corrosive areas? Again, you have to think about the application first before you select your materials, right? I mean, it's, call me Captain Obvious here, but you've got to think about where is this equipment going, and then that will help you select the right materials for your cable tray. So stainless steel, really good at corrosion resistance and temperature extremes, acids and chlorine, etc. So you have those for both indoor and outdoor applications. Fiberglass. Now fiberglass, you would think fiberglass is pretty cool. I bet you that would be really light. Yeah, lower weight than steel and stainless steel. But it didn't say aluminum. I'm surprised at that. Excellent corrosion resistance, obviously. Lowest thermal expansion. Now I wonder how fiberglass, I mean, I know you could use fiberglass outdoors. I guess it's all about how they build and construct from a strength perspective. Now when you think of strength and resiliency with regard to the physical construction, I think of a couple areas, not just because of the weight of the conductor. I mean, that's the obvious. But when it's outdoors, I'm thinking about wind shear, snow. If you're in the snow areas, what's going to be on top of, in addition to the cable, what else could possibly be on top of that cable tray? And then What about the wind? Right? Wind's going to be passing over it, down on it, up from the bottom. It's going to be shaking and baking that cable tray. So you've got to think about a lot more than just the weight of the conductor, because it really depends on the application. So again, understand your application. And then here's what I would do. I would not, even if I knew my application, let's say I'm putting it outside. Any of those applications that push the limits, right? I mean, if I'm in a data center and I'm carrying cable around the wall, all right, I don't have much to worry about. I don't have to worry about the elements outside. There's a lot I don't have to worry about. Wind shear, snow. I'm in a data center. I'm in a controlled environment. When I start to get in other areas, like if I know I'm in a caustic area, if I'm outside, I'm in near salt water, I'll tell you what I do. I know what I did. I always consulted the manufacturers. I would pick a few manufacturers. I would pick at least 3. This is what I used to, when I worked for a consultant, and this was a long, long time ago. This was, when God said, "Let there be light," a little bit after that. I would pick 3 manufacturers. And if it was a product, like, for example, I was at a nuclear plant and I was designing the security system. And we had to select, this was right after a gentleman drove through the gate at 3 Mile Island, drove through the front gate, parked his car and hit it. And it wasn't until a while after that they figured it out. And then they had to find him. After that event, the NRC, Nuclear Regulatory Commission, created a requirement that everybody has barriers, vehicle barriers, placed at the entrance to every nuclear plant. Well, I was in the middle of my upgrade and then this happened. And I remember Gar was was the guy I worked for. He was head of security. And Gar pulled us into a room, showed us the video, and explained what we would need to do. Thought about we had to come up with ideas. So I went online and I started researching these vehicle barriers. I called a couple other plants that were looking at it, and I picked 3 manufacturers. And I went out to each of them and I said, "Okay, here's what I got. Here's the road. I had pictures. This is what I need to do, what voltages, etc." And I let them give me their recommendation based upon my application. And then I evaluated their recommendations. And I'll tell you what, that worked out well for me, because the first thing that I had to do was admit I don't know a daggone thing about vehicle barriers. So the first thing you have to do is recognize you don't know anything about it. And when you don't know anything about it, you start to research. And I went to 3 different manufacturers, and they all gave me their spiel. And each manufacturer is going to have their secret sauce. And they're going to try to help you understand the importance of why this is a big problem, and then, oh, hey, by the way, we have this secret sauce that solves that. So you just got to be mindful of those, but you can learn a lot by talking to the manufacturers. And I tell you, when it comes to cable tray, I would seek a few out. And I'm sure that a few of those manufacturers have been at IAEI meetings. And I'm positive that I've seen cable tray and cable tray accessories at tables at either the section meetings or local chapter meetings and division meetings of the IAEI. So a great opportunity to build your contacts. Any of those trade shows, any of those events that you can get to where there are vendors, take those business cards, those are your contacts. But this slide sort of gives you an idea that there are different materials. And I'm sure for each of these materials, there will be varying applications. All right, enough said. Enough said. I call the question. All right, so codes and standards. You know what I said? It's funny, it was yesterday. No, my task group was on Friday. And we were looking at a public input. And And you know, when somebody has had a public input that we initially were like, we're going to resolve this. But then when we started looking at it, we're like, well, when you try to come up with the substantiation and you can't, it's sort of like, if I can't come up with a panel statement to support or resolve, then it probably should be a first revision. And so we started to do research, and we were doing research in the task group work, and apparently somebody was like, let's get moving on. So they called the question, and they ended the debate and the discussion. But it was pretty cool. Anyway, 392. Look at this. There is no such thing as a UL listed cable tray. Well, I'll be a horse's patoot. I did not know that. Hold on. So I said I would do this. I don't know if this is gonna work. All right, it's working. So I'm going to search cable tray, UL listed cable tray. Mechanical supports. There's cables, tray cables. So mechanical supports. And if I scroll down, cable trays. When performing electrical inspections, AHJs require metallic and non-metallic cable trays to be certified. We offer US and Canadian certification to meet these requirements, and can also offer testing and reports of some of these products for global market acceptance. We can also assist with accessing international markets with IEC 61. So you have non-metallic cable tray systems as UL 568. And metallic cable trays is C22.2 number. What is that? Let's search it. Copy. Paste. This is what we do. I'm teaching you how to fish. CSA. So that's a CSA, so that's a Canadian standards. CSA group. Metal cable tray systems. Binational standard with NEMA VE1, which is in here. So it's a tri-national standard. So this is the harmonized CSA group and NEMA standard for metal cable tray systems. It is the 4th edition of CSA C22.2. Number 126.1, superseding the previous. This harmonized standard was prepared by the CANINA. I'm on CANINA. I know what CANINA is. Technical Harmonization Committee for Metal Cable Tray Systems, comprising, not compromising members, comprising members from CSA Group, the NEMA, etc., etc. So I would argue that there is a tri-national standard that can't, and what did it say? This said, when performing electrical inspections, HJs require metallic and non-metallic cable trays to be certified. They offer US and Canadian certification to meet these requirements. So apparently, I'm not sure if the manufacturers list them or not, but there are some standards out there, and if you need them listed, I'm sure you can get them listed or field evaluated, one or the other. So that's an interesting. So 392.60A. 392. So remember, 392 is cable trays. 392.1 tells us this article covers cable tray systems, including ladder, ventilated trough, ventilated channel, solid bottom, and other similar structures. It tells you to see ANSI NEMA VE1, metal cable tray systems, and NECA NEMA 105, standard for installing metal cable tray systems. Why wouldn't it reference C22.2, number 126, or UL 568? That's a good question. It does reference NEMA, ANSI. Let's do this. Ooh, here's the other thing you do. If you go back to the back of the book, Annex, Informative Annex, I think it's 1. Informative Annex 1? Is it 1? Is it A? No, it's not A. Yes, Informative Annex A. So I'm going to go to 392. I'm going to look what they have in Informative Annex A. What Informative Annex A has are all of the standards. And what's really nice about Informative Annex A is it goes by article. Now, what I wish it would do is by section. But if you go to the article, it'll tell you the standards that are associated. So 392, if I go to 392, it has UL 62275. But that's for cable ties. Cable management systems, cable ties. So even the Informative Annex A doesn't reference C22.2 nor UL 568. Das is interesting. UL. Oh. So this is another tool you should have, CSDS. I believe login is free. So if I go back to this, for the standards, UL 568. If I type in 568 over here, 568. Bada bing, bada boom, bada bang. Non-metallic cable tray systems. And I click on follow, and now I can see the work areas. Valid and commenting reaffirmation of UL 568, open 2023. Interesting. So, you see my dilemma. I don't have those standards listed in Informative Annex A. It's not referenced in the informational note. So I would argue, if you are interested, I mean, you could call the manufacturers and find out if they have listed product. I'm sure the accessories and whatnot are probably listed. I can't say I'm sure. You may want to discuss that with the manufacturers. But NEMA VE1 is one of our references. Now, this is sort of an overview. You've got the IEC, which is the international standards. NEC, which is really like, I would say it's the Americas. NEMA is a manufacturing group, but we do write standards, or NEMA does write standards. Underwriters Laboratories. They write standards, they list and classify product, all that jazz. CSA, we just went out to their site, we saw that. CSA, Canadian Standards. They write code too. Lloyd's Register. the DNV, ABS, FPEL, and powered by Achilles and ISO. Those are your different types of standards and bodies, and what the sort of a categorization. Now we know we referenced Article 392 for the NEC. We had Underwriters Laboratories from a listing perspective. CSA is another one. IEC from an international perspective. NEMA. We mentioned already a NEMA document, which we'll go out and find that. So our codes and standards come from different areas. So you've got to think about the different areas that, different types of documents that are out there for you. There's a lot of good references around cable trays. 3 key areas that we do from, I would argue, from a product testing perspective, but also from an application perspective. You've got load, that's how much weight. You have the grounding and bonding of the equipment. You have impact. So, and I would argue that you'll have a feeling for what the busway may experience based upon the application. Right? If I was putting, not busway, if I was putting cable tray, how many times did I say busway? When did I take that leap? Why the heck did I say busway? You can think about, if you think about cable tray in various applications, that cable tray that was in that dwelling unit in the basement, it's not going to see wind, it's not going to see snow, it's not going to see rain. Could it see additional load? I can see. I mean, if I'm in a hotel room and the sprinkler says do not use as a coat hanger, do not hang your coat hanger on it, you know the homeowner is probably going to hang something on that cable tray. Think about it. You have to plan for those types of things, right? So, depending upon where it's at. So the load and the grounding, grounding is grounding. I mean, we're going to talk about that, but and then impact, what may hit your cable tray. If I have it outside, could a tree hit it? Maybe. Do I have to plan for a tree? Not necessarily, but if you have a lot of trees around your cable tray installation, you either should clear them or plan for trees. That's my thought. Clear them or plan for trees. All right. What we tried to do here is identify some of the standards for each of the phases, right? So you have your preliminary design, you have your final design, your bid and buy. These are your distributors, procurements. This is when you're going to say, hey, if I want it listed. Installation and completion. Installation and completion, your codes and your inspections, etc. Usually your third parties are present in basically involved throughout all of the stages, I would think. Now, these are your 2 key documents. NEMA VE1, so here's what we're going to do. We are going to search for NEMA VE1. NEMA VE1 is right here, metal cable tray systems. And this could be yours for $126. The published date is July 14th. It's, okay. specifies requirements for metal cable trays and associated fittings designed for use in accordance with the rules of the Canadian Electrical Code, Part 1, and the National Electrical Code. So here's the thing. My gut tells me this. When I see something that says requirements for metal cable trays and fittings, I think this is probably meant for manufacturers, not for you all. Now let's go to NEMA VE2. VE2. NEMA VE2 is cable tray. Geez, oh man, I'm having issues. Addressing cable tray installation guidelines, addressing shipping, handling, storing, and installing cable tray systems. Ooh, maintenance. OMG. Let's go to NFPA link. Let's go to 70B. I didn't think about this. And do we got panel boards? Let's say busway, circuit breakers, fuses, switches, power cables, cable tray, chapter 19. So we have a chapter 19, which is pretty doggone short, but we do have, and it's a free download. So this one's free. All right, so here's my thought. The first one is probably for if you are a manufacturer, these are like it's like the product standard. This document, the second document, the VE2 document, this guy right here, while that downloads. The VE2 document is your how-to guide with methods for proper handling, storage, and installation. So the first one is more for the manufacturer. The second one is more for the application. So there's your, just look, okay, let's just take a look. So sometimes the outline can give you a heck of a lot. Cable tray installation locations, common tools, support, trapeze, the Great Wallinda, hanger, rod clamp, center hung support. So they got different types of supports, straight section installations. Oh, this is perfect. Fitting installation, field modification, accessories, like your barriers, grounding and bonding. Oh, they even tell you how to install the cable. Now there you go. Maintenance, inspection, inactive or abandoned cables, adding cables, typical cable tray types. You have your cable ladders, single rail, solid bottom, trough, ventilated, wire mesh cable tray, channeled cable trays. So, and then there's some tables. Oh, like a fastener, torques. You know, I just worked on my tractor this weekend. What did I do? Oh, I took the blades off. I put new blades on my, I guess, I can't call it a tractor for all of you out there in Texas, right? Or was it North Carolina? I can't remember which one complained that I called it a tractor, but it's a diesel GR 2120 Kubota. And I had to look up the torque values for torquing down the blades. And I found it pretty doggone good. And I used my torque wrench. I bought two torque wrenches. One's a larger one, and the other one is smaller. And I used my torque wrench, and don't ask me when it was calibrated. Metal area. So there's a lot of great information in these two documents. The second one is free. I would ask you to get out there to the NEMA website and get it. All right, VE1, by manufacturers, for manufacturers. Geez, oh man, I should have read my own slides. Typical dimensions, testing methods, all that good stuff. Tests are set up and conducted in always simple span, one tray support, no splices, span, tray length, tray ends, clamp down, etc. Typically, third-party observers are not present. 36-inch wide, is tested in a long length. Results are displayed in a table. Results displayed do not include deflection values. There you go. Look at that. How that's set up. That's pretty cool. Maximum deflection, worst case load, loading to destruction, 1.5 service factor applied. That's your simple beam. And look how they lay that weight, those weights, they're in bars. Those are long bars. A NEMA load class is a combination of a number and a letter, such as 20C. So A equals 50, B equals 75, C equals 100. That's all pounds per foot. Those are your spans, 8, 16, 12, and 20. A 20C cable tray is a tray strong enough to support 100 pounds per foot of cable weight when the tray is supported every 20 feet. Well, I guess that's interesting. £100 as long as you support it every 20 feet. So this is your cable tray installation guidelines. This is that free document. I showed you how to get that. By manufacturers, for designers and contractors. It's a NEMA publication, National Electrical Manufacturers Association. Support installation, location of the supports. They tell you how you're doing your field modifications, any grounding and bonding. That document, in my opinion, that document is the cat's meow. A support span should not be greater than the straight section length. Ooh, that's interesting. Remember, a straight section length will be from splice point to splice point. There's no splices, so it's a solid piece. Or as recommended by the manufacturer, to ensure no more than one splice is located between supports. So now it says, or as recommended by the manufacturer. So it could be that depending upon the way each manufacturer splices the tray, you may get some special considerations, so to speak. You may get some special considerations if they have, like, say, special splice joints or something. I don't know. I'm just saying you'll want to consult the manufacturers because it says or as recommended. So get the instructions from the manufacturer, and there may be products that they offer to reduce the number of supports. I'm just guessing. I'm out on a limb. And you know what happens with that limb. So in any case, you'll notice your typical continuous span configuration, maximum positive moment, etc., etc. Right? So whenever you get a splice point, that's when you got to pay attention to the details. Oh, now this is vertical. Now, vertical supports are just as important as your horizontal supports. These are going to do two things. It's going to keep it from falling away from the wall, but also from coming down off of the wall. Now you're dealing with shear, right? So like on a bolt, you're dealing with when you have cable tray sitting on a truss. So say I wish I had a cable. Let's say that this is my support and it's horizontal and my cable tray sits on top of that. My bolts that are in there are not necessarily experiencing the shear. They're experiencing some, but if I'm supporting it this way and I'm securing it this way and I'm relying on this bolt, now the shear of the bolt is what is probably my weak point. In any case, there are different ways that you need to make sure that you're supporting your cable tray. I keep wanting to say busway. I don't know why. So write something down. Okay, so oh yes, cable tray can get. Now I've seen some very complex cable tray systems. In this, again, you're in industrial facilities. These systems, T's, X's, going from one level, either going this way and up, vertically, or even horizontally, right? All of those, and they all have to be connected. So you have to think every one of these joints and angles and special configurations have to be connected to the rest of the busway. You want to make a continuous run. You want it all to be supported with each other. They'll tell you, VE2 tells you, supports have to be within 2 foot of adjusted splices, and supports within 2 feet of expansion splices. So when you look like right here at this one here, that's a weak spot for obvious reasons. And look how they have a support on either side of that splice, we'll call it. I'm going to call it a joint. There's an actual picture, and you'll notice the bonding. So they're making sure that the bonding is secured from one tray to the other. And all the metal is all connected together, and every one of those terminations, you have to think about the materials that you're terminating and make sure that you don't have dissimilar metals and galvanized, all kinds of stuff. So you got to follow the manufacturer's instructions, make sure you buy the right parts and pieces. But that is not supported on either side of, if I can do this, whoop, go back. For some reason, I can't get, so I have a support here, and I should have a support over here, and I do not have a support on both sides of that junction. All right, safety sizing control. These are their standard widths. You have a ladder on your rung spacing, solid bottom, and you remember, if you're using solid bottoms, if you are in a rain environment, you're going to have water settle in there. So you've got to consult and think about the application, whether you're going to have rungs, and then how far apart are those rungs. Lengths in 10 to 40 foot. That's a lot. 40 foot's a long length. Fittings and bending radiuses. Article 392 of the NEC determines work. Okay, so cable tray width. Required cable tray width. So if I go to 392, allowable cable fill is in 392.22A1. You have the maximum allowable fill area for multi-conductor cables in table 392.22A5. Allowable cable fill areas for multi-cables. You got your ampacity of your conductors, Metal area requirements for cable trays used as equipment grounding conductors. This is your maximum fuse ampere rating, circuit breaker amp trip setting, etc. And then you have your maximum cross-sectional area of metal with steel cable trays or aluminum cable trays. Fiberglass isn't in there. I wonder why. Really? Why wouldn't fiberglass be in there as a bonding, as a grounding? Come on. You know, where's those wooden ground rods, right? So the way, let's just talk, since we mentioned Article 392. The way our Article 392 is laid out, you have Part 1 is general, which only has the scope. Part 2 is your installation. You have uses permitted in 392.10, uses not permitted in .12. You have 92.18 is your cable tray installation, complete system. Cable tray shall be installed as a complete system. You got your covers, trough partitions and walls exposed and accessible, adequate access. In G is raceways, cables, etc. You have marking requirements in H. Marking requirements in H. You've got cable and conductor installation in 392.20. And then 392.22 is number of conductors or cables. And then this is where the 392.22A1 table comes into play. It tells you the inside width of the cable tray in inches. And then it tells you the number of the maximum allowable fill area. And then you'll calculate the maximum number of conductors because it depends upon the size of the conductors that you're installing for obvious reasons, right? And let me keep going. Securing and supporting starts in 392.30. So you have your cables and conductors, you have expansion splice plates, you have bushed conduit and tubing, trough-based, etc. You got grounding and bonding in 392.60. 392.80 is your ampacity of conductors. So this is going to help you determine the ampacity of the conductors. Gotta love this. And then part 3 is construction specifications. You have strength and rigidity, smooth edges, corrosion protection, side rails, fittings, and then non-metallic cable tray. And they have to be flame retardant material. So in any case, side rail height generally depends on the required load. Majority of a load carried on the side rails. We already said that the weight is depending upon the cable, or the side rails. So cable strength, so the width ends up to be governed by the code, right? It's in your required fill areas. Cable type, cable voltage, diameter, tray bottom type, whether it's ladder, solid, trough, and then cable fill, right? So if you have X amount of cables, that's going to determine, the table's going to tell you what your fill area is. You're going to do your calculation, and that'll determine how many or how many trays you're going to need. You have communication cabling as a 50% fill ratio. Calculation tray area is if it's 12 by 3, 36 square inches, 50%, 50%. 50% fill is your 18 square inches. And then your cable area depends on, again, depends on the cable and all that good stuff. So in this case, for these cables, you got 520 cables you can fit in there. And remember, when it comes to communications, you're not worried about derating for ampacity and things like that. It's communications. Power cables, multi-conductor, 4-aught and larger, 392.22A1A. We just mentioned that, 392.22A1. A1A, where all the cables are 4-aught or larger, the sum of the diameters of all cables shall not exceed the cable tray width, and the cables shall be installed in a single layer. Where the cable ampacity is determined according to 392.80 A1C, the cable tray width shall not be less than the sum of the diameters of the cables and the sum of the required spacing widths betwixt the cables. So in some cases, you're going to have space in between cables, and in other cases, you're going to be able to put those right next to each other. And like what we're showing on the screen here, we have them right on top of each other. For smaller than 4/0, table 392.22a, column 1. That's your smaller than 4/0 conductors. All right, so you're going to have to do a cable fill calculation based upon the diameters of the conductors. You may have to put them in one single row, only one row, and you might need space in between conductors. That's going to all determine the size of, and then the weight is going to be associated with that as well, right? Now, these are your power cable single conductors, similar fill rules as multi-conductor, 392.80A2D, 392.80 ampacity of conductors. A2D. A is ampacity of cables rated 2,000 volts or less in cable tray. And 2, single conductor cables. Okay. And then D, jeez, oh man, where single conductors are installed in triangular or square configuration in uncovered cable trays with a maintained free airspace of not less than 2.15 times one conductor diameter of the largest conductor contained within the configuration and adjacent conductor configurations or cables, the ampacity of 1/0 and larger cables shall not exceed the ampacities of 2 or 3 single insulated conductors rated 0 through 2,000 volts supported on a messenger in accordance with 310.15. Woo! That's a mouthful. With not less than 2.15 the conductor diameter between groups. So you have to have spacing between those groups. And you know what they're going to use? Tie wraps to hold those in place. And they're going to be listed. Remember, we saw the standard earlier. Go back, rewind, take a look. I love it. Permits cable tray to be classified and used as an equipment grounding conductor. And it has to comply with 392.60b. 392.60b. 392.60 is grounding and bonding. B is steel or aluminum cable trays. Steel or aluminum cable tray systems shall be permitted to be used. You know what? Here's my thought process. I wonder, so you want an effective ground fault path for what reason? To trip the overcurrent device, right? So that means that if I have 400 amp worth of, if I have 400 amps worth of conductor, I want enough current greater than 400 amps. I want my ground fault currents to be greater than 400 amps to trip the overcurrent device. But what if I put ground fault protection of equipment? And now I could go at 30 milliamps. I could go at 100 milliamps. I could go at 5 amps, 10 amps. Remember, ground fault protection of equipment doesn't have a specific value. My effective ground fault current path is current going outside the path. Anyway, there's all your warnings, cross-sectional areas. There's all your do not use as a walkway. Don't walk on these things. They have your maximum area. There's your UL label. You want to keep the bonding. You're going to put the straps around the joints. And even if you have a splice, you can't rely on that splice. You're going to put the conductor around that. And you look on the second one closest to me. This is when you're dumping into a trough. You're going to have to make sure you maintain the bonding jumpers in all the right locations. You may need to have a fixed solid barrier of comparable material to keep your different voltages separate from each other. For raceways terminating at the tray, a listed cable tray clamp or adapter should be used to securely fasten the raceway to the cable tray system. So this is like your cable's dumping into the tray, and you're going to want to make sure it's listed, and the clamps and all the fittings and hardware that you're using are listed for that application. Where you have continuous cover for more than 6 feet, not over 95% of the allowable ampacities are permitted. Remember, I'm keeping in heat. The moment I throw a cover on there, I'm retaining the heat, and heat matters. Now let's take a look at some cases. We'll close out our hour-plus adventure. Case study number 1, there's missing supports. Look at that. Look at that cable tray. Look at this tray right here. Look at that sag. Man, that is ungood. Not good. And look why. You have these supports. You need within 2 feet. You need one here, you need one there, you need one there, you need one there, you need one there, you need one there. Right? You need them in all these locations within 2 feet of each joist. Cable trays shall be supported in intervals in accordance with the installation instructions. What it says. VE2, you need around each of these joints, splices. VE2 section 4.3.3, for changes in vertical direction not requiring a radius, vertical adjusting splice plates can be used. Supports should be located within 2 foot of each side of vertical adjusting splice plates. Addition of supports resolved both identified issues. This is case study number 2. If your raceway looks like this, you didn't do something right, right? I love this stuff. You can't make this up. Look at that. Vertical runs, long horizontal runs. Expansion and contraction has to be accounted for. If you don't, they'll start to buckle like this. This is ungood. A supported splice. Oh, you know what? That's not good either. If the manufacturer tells you you have to be within 2 feet of either of that splice, putting it on the splice is not a good solution. You want to be on either end. Requires supports within 2 foot of both sides of an expansion splice plate. Within 2 foot of both sides. Putting one in the middle is not a good idea. There's your splice plate. This is the support. There's your bonding. You're going to need to make sure that you are within 2 feet and you have 1, 2 on either side of this. Putting one right in the middle is not a good idea. Simple beam causing maximum deflection due to maximum positive moment at the support location. That's what you get if you put your support on the very far ends. You bring these supports in on either side for better support, to minimize your deflection. Potential for cable tray guide to interfere with the splicing hardware. Oh, and yeah, you could interfere with the splice itself, with your hardware. Splice locations at 1/4 span, aesthetics, minimum deflection reduced by 50%. NEMA 432 supports within 2 foot of expansion joints. So when you're dealing with hanging up tray, you got to think about those expansion joints or all of those sections where you're coupling those sections together. This is another ungood thing. Look the way they put that raceway. Dump into the cable tray. Don't drill through the cable tray. You ruin the integrity of the sidewall. And remember, the sidewall is what is giving you your strength. Must be sized relative to the side rail. You have conduit tray adapters. in my opinion, well, your best bet is to dump into the tray. Come over the top and dump in. Don't come through the side rail. Creative support methods. Look at this one. You don't support tray on tray. If it's listed for that, then you're good. You don't want to do that. You want to make sure you're using the right listed parts and pieces. You don't add all thread. All thread isn't for all solutions, all right? It's good for some things. So splicing, long straight runs, expansion and contraction concerns. You've got to think about the aesthetics, any deflection that you're going to have, etc. So in outdoor applications are unique, but I'd argue even indoor applications as well. Depending on the facility, you can get pretty crazy with cable tray. I've seen it. Splice locations on supports are always going to be a challenge. Anytime you have a splice, cross your T's and dot your I's, right? Make sure you're thinking through the details. Splicing on support creates issues. Simple beam causing maximum deflection. And you might be trying to do this to minimize the number of supports that you have to put in, which reduces cost. But you've got to be mindful of that. Now, there are some manufacturers may give you expansion splices that are heavy duty, or they may have other types of solutions. I don't know. Talk to the manufacturer. Tell them you want to reduce the number of structural support members that you have to support the it's not busway, the cable tray. Why do I want to keep calling it busway? What's wrong with me? Willie? What the heck? Robert? Where's my head going these days? So anyway, you'll want to find the right solutions. There might be a lot of different solutions on the market to help you with all different types of applications. You know, these pipe racks and the way that the hangers, the trapeze, there's a lot of different solutions for when you are dealing with dealing with cable tray. I would argue that when you're dealing with cable tray, bonding is obviously a very important, probably a detail that's missed often. But I would argue that the supports are probably your second area of major concern in the application of cable tray. Think about the materials that you're using as well. Make sure that the application has the right solution. All right? And we went well over our hour. I apologize. Hopefully you got something out of our discussion today. For this IAEI News Live, my name is Thomas Dimitrovich. And I'm going to call this IAEI News Live to an end. Thank you for watching. Thanks for what you do for the electrical industry. Thanks for what you do, especially for electrical safety. Remember to stay safe and please stay healthy. See you next week.